Alright, welcome back. So, we're going to continue off where we left, and that's going to be our, what do we call, AI. So, to begin with, we got our objects here. We made some changes here and there, and the main change we did was we made Pathmaker a dependent class. So, what we're going to do is we're going to have the shooter AI actually call on the Pathmaker and then decide where we want the object to be. So to do that, we actually made two changes here, and we can check it here. So the first change was the Pathmaker. So instead of having a node to call and change it, what we're gonna do is we're gonna have it procedurally fix it up. So the first change we did was we made it we saved ourselves some lines, because now no matter how many points you have, it's going to automatically decide / set them properly. So you don't really have to write the 0, 1, 2, 3, 0. It's going to do that circle by itself. Then the next thing we did was we made all of them public. Then we moved each one into their respective functions. Then we got a function that calls on the current position it is in. Then we got the move object, which what we had, we just moved it, and now we have that node to move. And then the next thing, we made that render path into a function, and we made it a public function. So everything's public, so we can call it in another program or the other class. And then on the shooter AI side, what we did, we got a Pathmaker node which connects our Pathmaker. Then at the same time, we did a few more things. So one is we called on the Pathmaker path, and that gets the component from the node that we connected, and then it's connected. The next thing we did was we had a few new over here on our update, and if you put new on updates, they're gonna just slow your FPS down. I know there's one somewhere in another file. I'm gonna have to find it, but until then, yeah. The next thing I did was just add material for view, made a new once, so it's gonna be reused and recycled, saving us some efficiency. The next thing was if we go down, 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 I made two functions, and they're called rotate towards, move towards. Both have these, and we're gonna fill them up right now. So let's go back in here. So the first thing we're gonna do is actually we're gonna initialize the path. So we're gonna go path dot, can't press dot anymore, init path. So now that creates our new path, and then it fills it up with the points and the segments that we had, right? Then the next thing we could do is actually render the path right here. So path dot render path, and now we have the path shown in our dude. So the next thing we could do is actually get the main character, which we do right here. We got him, and now we can just always connect him or like find out his state, status, etc., etc. So what's next? Let's actually write these two codes. So what we're going to do, actually no, let's write the logic first of all. So the reason why we're going to write the logic is because then it'll make a little bit of sense to everybody. So the first thing we're going to do in idle is we're going to first check node.worldPosition, right? And we're going to check the distance between the node itself, so the enemy that we are, and the position where he wants to be patrolling. So we're going to check that distance, see if it's greater than a certain number. If it is, then we move towards it. But if it's not, then we just do our regular patrolling. So we can do mathlib dot distance, and we use the distance node dot world position. And for the other one, we use path dot get current path position. All right. And give me a second. All right. And then once we have that, then we ask if it's greater than 0.1f. So oh, we'll give it like a really small number. So if it's greater than 0.1f, we get the guy to move towards the thing. So we do move towards, and where are we moving to? We are going to move to path dot get current path position, and we're gonna move the node itself. So now it's gonna move towards that. We can also rotate towards it. So we can do a rotate towards, and we can just copy and paste this. So now it's gonna copy and paste, and then we also have the speed, how fast we want it to move. I mean, how fast we want it to rotate. I'm just gonna say 0.05f. It's good enough. All right. So if it's far away, it's gonna move towards that position. Else, but if it's not, let's say it's already in that position and you're idling, so you're gonna now patrol. So now you're gonna do path dot get set. Can't even remember what was the functions. It was move along path and move object. So we're gonna do path dot move along path, and then path dot move object, and the object is the node itself. Okay, so that's our logic for while we're patrolling. Now let's say if we get caught, what are we gonna do? So if we get caught, what we could do is alerting would be we don't move, but what we can do is we can rotate towards. So we look towards the dude. So we look towards main character dot world position, so where he's at, our object, and then the speed 0.005 f, and that's a good speed. All right, now if he stays there for long, he gets into aggressive, and if he gets into aggressive, then what we're going to do is we're gonna now move towards him. So main character dot world position, our object, and it's gonna move on its own. Then the next thing we're gonna do is also rotate towards him, and we can just copy and paste this, and instead of 0.005 we can make it 0.05, which is pretty fast because it's rotating every tick. It's not rotating every second, it's rotating every tick. So that's being sent every tick, so that's a good amount of speed. Now the next thing we can do is in search, we can have him just look around and not do anything else. He doesn't want to look at the character, he just wants to look around. I think that's good enough. We could do something extra later on, but for now, let's just say he knows you're there. He just doesn't want you to get close to him. So we could do that. And okay, so now we got alert, we got our idle, we got our search, and we got our aggressive. Now everything looks clean. So let's clean this up by adding our functions. And what we're gonna do is we're gonna code the rotate towards and that. So we can do a vector3 vec1. So point 1 would be the object to move dot world direction, and we could do the direction y. So that's 1. And then for vector 2, we're gonna have 2 vectors, and the vector 2 would be let's see, don't really need that. We're gonna do the towards object, so the object we're looking at dot world, well actually no, towards object is a vector 3, that doesn't really need that. We're gonna do the object to move dot world position. Okay, and the reason why we did a minus is so that it does vector subtraction, so we're on the same page, nothing too fancy. And then I think we can do a dot normalize. Okay, so we could do that, dot normalized, and we could just put these both in bracket, and it can normalize it for us, saves us a step. We could also just write vector2.normalize in the next line as a function, but either ways. Float, next thing we need is an angle. And what we do is we do a mathlib.angle. And we've done this before, so it's nothing new. So we just take vector1, vector2, and we take vector3 dot up. So that saves us that time. Once we do that, then we're gonna do object to move dot rotate. Okay, now as we're rotating, we want to reset the x's and the y's. And the reason why we want to do that is because the object could be tilted in a specific way. So we're gonna reset that. So we're gonna do minus object to move dot world rotation dot x. All right, and then we can just copy this and then paste it and turn it to y. And then for this one, we're gonna do angle times speed, and that should be that. Okay, so we're gonna see the magic happen soon. As for move towards, let's do a vector3 position. So now we're gonna take a position, and it's gonna be a lerping position. So we take a position from between these two, make a line towards it, and then give it a percentage between where it's going and it's gonna go. So we're gonna do mathlib.lerp, right? And then it's gonna ask for a few things. So we're gonna first do object.move world position. Then we're going to do towards object. And then the last thing we're going to do is game.ifps, but we're going to divide it by the distance. So the reason why we're doing it is the game.fps goes in a specific percentage, so it'll give you 1 in a second. And if we divide it by the distance, so if it's 8 units long, it's going to take 8 seconds to get there. Pretty fair, pretty standard. And distance, and then we do that. Let me just close it. The distance required are going to be the two things over here, so we can just copy and paste this and just do that, and then we can delete that. All right, and now it's connected. The next thing we're going to do is just a simple object to move dot position, actually dot world position equals to position. All right, so that connects everything over there, and then this connects everything over here. Hope I didn't do anything wrong. Let's check it out. All right, so our dude is now walking towards the first point, which is over there. Once he gets there, he's gonna start his patrolling by going on to what he was supposed to do. He forgot to roll. That's okay. We can do that logic later. All right, he's here, he's going through. Let's get into his range, and as you can see, god damn it, so hard to get there. He's alert, he stopped moving. He's idle, he's moving. Oh no. As I said, that new function is ruining it. All right, he's on alert. He's looking at me, and now he's aggro. So he left his position, and now he's chasing me, right? So he left his position, and now he's chasing me because I have aggravated him. Let's run away from him. He is trying. Now that he's in search, he knows I'm in the area, but he just doesn't want me to get into that area. So now he goes back into idle, where he was last at. And then he's just going to teleport exactly back in, and bam. All right. He saw me for a second, so he was just making sure. And we go back, and not bad. All right, so we got the logic here. We can check it one more time. All right. As you can see, we kind of broke him. All right, never mind. There you go. Okay, maybe because he's too far up, or like my first thumb's not that big. It's pretty small. So we can do that, and now he's just gonna attack us, or try to attack us. Anyways, so that's our AI logic. We can run away. He's on search mode, and then he's gonna go back into his thing. So that's how we make a simple AI. And to be honest, we can make this more, what's it called, advanced. But for now, this does a good job at behaviorism and introductions. All right, with that, I will leave you off. Next episode, I'll see what I can do. But for now, I need to fix that. So, I'll see you again next time, and goodbye.